Okay, we're going to go over this half-life formula. So it's another um, exponential function equation where you've got some situations where you'll need to use the logarithm to help you solve it. So I'm looking at this, get this straightened up here. There we go. Formulas n equals NO to the 1/2 times 1/2 to the t over h power. So the n is going to give you the amount that's remaining, so whatever's left. The NO, that's the original amount. And then it's a half-life, so it's 1/2 raised to whatever power. And however long that half-life is of the particular isotope or element is the h, and the elapsed time would be t. So if whenever your half-life and your time are equal, then it gives you exactly half. So this is a way to calculate it based on whatever time you've got or whatever amount that you have left. So for number 4, we got the half-life of sulfur 35 is 87.1 days. So it says that's the half-life. 87.1 days would be the half-life. How much of a 2-gram sample will remain? So that's the original amount. And how much of it will remain after 100 days? That's our time. And we're just going to make sure days and days are the same thing, so we don't need to adjust those at all because they are the same. And so I'll fill those numbers into my formula. And this one, since we're first working with the formula, it's just solving for n. And so that would be 2 times 1/2 to the 100 over 87.1 power. And so you can see we're dealing with a lot of exponents that are different than just whole number exponents. So we'll just take that and plug it into the calculator. Have a lot more difficult time solving it without. So 2 times 1/2 to the 100 and the 100 over 87.1. And so the amount that would be remaining would be 0.902, or about 0.902 grams that is left. But since this is using logarithms, we are not just going to be solving for the amount there, or either of the amounts. You've got ones where you'll be solving for the amount of time and the half-life. So let's look at the formula for that. If I take number 5, we have a half-life of 23 hours. How long does it take 50 grams, so that's your initial amount, to decay to 40 grams? And so what we're missing is time. So let's go over how we're going to figure out what time is equal to. And so here's my original formula. N equals NO times 1/2 to the T over H power. Okay, and so I'm going to go ahead and we're going to work through and solve this for T. And just using our rules and what we know, I can start out by moving that NO over. And so very similar to our other equation that we get rid of the part that's in front first, so that p-value or that deposit, same thing. And so I have N over NO equals 1/2 to the T over H power. So with that, in order to get something out of the exponent, the tool we have for that is to take the log of both sides. So that's going to be our easiest thing to do here. Because if we're trying to move this exponent out, I could, if this was 2, I could take the square root of both sides. But since I don't know what the value is, we'd be doing N over NO to the T over H root, which again doesn't really help us much, or doesn't really help us at all for that matter. So if we take the log of both sides, what's going to happen is this exponent can move out front, and the exponent just stays as T over H. So when I move that out front, I get the log of N over NO equals T over H times the log of 1/2. And now, since that's the log of 1/2, we could find what the log of that is and use it as a constant number there, but it's going to be more accurate if we just leave it as the log of 1/2, because I get some long decimal number. So what I'm going to do now is divide both sides by the log of 1/2. And that ends up giving me T over H equals the log of N over NO over the log of 1/2. Okay, now we've got those numbers. We could solve that and then multiply it by H on both sides. But what I really want to do is let's get this formula adjusted to where we have a formula to solve for time. And for that matter, we'll adjust it for 6 to get a formula to solve for the half-life. So basically what's going to happen here is I have T over H equals this whole left side. So I'm going to end up multiplying both sides by H. And when I do that, I'm just going to reverse it around. I get T equals H log N over NO over log of 1/2. And so just like that, we have a formula to solve for time. Right now, if we take and go back a step to what we had right here, because to solve for half-life, I have to get that fraction that was an exponent on its own first. So I'd be working through these same steps up until here, which would be log of N over NO over the log of 1 over 2 equals T over H. So that's just this right after I've divided. Got that right there. And if I'm solving for H this time, what I end up doing is cross multiplying. So h is going to move up there. Log of 1/2 is going to move up there. And then I'll divide by that log of n over NO. So we'll write it out as a couple steps. When I multiply that, I get h log of n over NO equals t times the log of 1/2. And to get h by itself, just divide by that log of n over NO. These cancel out, and I end up with half-life equaling t times the log of 1/2 over the log of n over NO. And makes sense here because basically this is just this same formula, just the whole thing flipped over. So when I had t on top, h on bottom, NO on the log of n over NO on top, log of 1/2 on bottom, flipped it over to where everything on the bottom is on the top, and then just move the t up. So works and gives us a formula to solve for half-life there. The great thing about this is now all I've got to do is, since I've got my numbers, we'll just plug them in. So t equals h, which was 23, times the log of n, which is 40, over NO, which is 50. And all that is over the log of 1/2. So we'll just type that in. And so I've got 23, or let's go ahead and set up our fraction. 23 times the log of another fraction, 40 over 50, which you could simplify into say 4 over 5, but we'll keep it looking just like it is, over the log of 1/2, which again, you could put as 0.5, but we're just keeping it exactly like it is. So got that in there. My answer should be my time. So how long does it take to go from 50 to 40 grams? 7.404 hours. Hey, and for the next one, we've already done a formula for it. And so it says we have 35 kilograms of a 100 kilogram sample. So N value is 35. The initial value was 100. And it says time 12,000 years. So I don't know who ran that experiment, but these are the numbers we've got. So again, we've got our formula that we built here. We'll just plug those numbers in. So H equals 12,000 times the log of 1/2 over the log of N 35 over NO which is 100. And same thing, we'll plug that in. You can even, since the format's basically the same, I could take and use that and just change some numbers around. So it might work for me, might not. Yeah. So doesn't quite work for me. Log of 1 over 2. And this is going to be log of 35 over 100. So let's make sure 12,000, log 1/2, log of 35 over 100. So it looks like our half-life of that carbon-14 would be 7,923 years. It says round to the nearest 100 years. So we'll say H is about 7,900 years. So a lot of this was adjusting formulas around. But the good thing about that is if you've got them or you've got an idea of how to work through those and find them, then you'll be able to use those formulas, get those formulas whenever you need. And then from there, it's just a simple, okay, let's plug this in. So use those formulas absolutely as you're working through solving those. Makes it a lot easier. Just make sure you have right thing in the right places, identifying the numbers correctly, and you should be good to go.